A warm welcome to all. This is Dr. K. Muruganandan, Assistant Professor from the Department of Mechanical Engineering. Today we are going to discuss about mechatronic system, a case study of washing machine. Let's we discuss about the mechatronic system. A mechatronic system is a closed loop that integrate mechanical, electrical, electronics, computer and control engineering, where sensors give feedback to the controller to operate actuators for accurate performance. Simply, we can say it is the technology that brings together mechanical parts, sensors, actuators, microcontrollers, and software into one smart system. Sensors. A sensor is a device that detects or measures a physical quantity like temperature, pressure, speed, light, and converts into a signal that can be read or processed, which means electrical, pneumatic, or mechanical. So generally, there are n number of sensors. So mostly we are using potentiometer, LVDT, capacitance sensors, strain gauges, Hall effect sensors, temperature sensors, light sensors. The potentiometers are generally used to measure linear or angular displacement, and LVDT is used to measure linear displacement using variable mutual inductance. And then capacitance sensor, which is used to detect displacements and pressures, and then the strain gauges, which is used to find the deformations or measure the strain by change its in resistance. Hall effect sensors, it detect speed, position, and magnetic fields. So generally we know that the temperature sensor used to measure the temperatures and volt, current, etc. And light sensors used to detect light intensity and convert into electrical signals. Today, I am going to talk about the case study of automatic washing machine, which is a very good example of mechatronic system. This diagram helps us understand how different parts of machine works together in a systematic way. Just like a human body has nerve system to control movements, the washing machine has control unit that coordinates all operations. Around this, we have input devices, sensors, actuators, and mechanical system. On input side, the user interacts with machine through the program selector or control panel. In older machines, this was done using mechanical timer, but in modern machines, it is done electronically with buttons or touch displays. For example, if I want to wash delicate clothes, I select a gentle cycle. If I want to wash heavily soiled clothes, I select a strong wash with hot water. This input is then sent to the control unit as a set of instructions. The control unit is the brain of washing machine. It may be a microcontroller or electronic circuit. Its job is to receive the input instructions and convert them into control signals. Think of it like a teacher in a classroom. The teacher receives the timetable and then instructs students when to read, when to write, and when to stop. Similarly, the unit cells, the control unit tells the motor when to rotate, the valves when to open or close, and heater when to on and when to off. It has the main parts like motor, water inlets, and then like hot water and cold water, and then drain valve and water outlet. For example, when the wash cycle begins, the control unit sends a signal to open the inlet valve. Once the correct water level is reached, the water closes and motor starts rotating the drum. Later, when the rinse cycle is over, the pump activates to drain the water. Now, if we connect these all blocks, inputs, control unit, actuators, and sensors, we see a continuous loop. The user sets input at input devices, which means timer and what kind of washing we are going to do. And then the control unit sends signals to the actuators. Actuators perform the washing actions, and then the sensors check the results and send feedback. And then the control unit makes corrections if needed. This loop continues until the cycle is complete. Such a closed loop design ensures accuracy, safety, and efficiency. Now, let's we discuss about the various sensors used in modern washing machine. Firstly, level sensor. Level sensor measures the water level inside the drum. It prevents underfilling, hence we can avoid ineffective washing. And also it prevents overfilling, hence we can avoid water wastage or flooding. And also it ensures correct water to cloth ratio. So finally, it informs to the control unit when to stop water inlet valves. So generally, pressure sensors are capacitive sensors are used for level sensors. And then temperature sensor. Temperature sensor monitors and control water temperature. It protects delicate fabrics. It helps in stain removal. I mean hot water for greasy stain. And also it saves energy by avoiding overheating. It maintains optimal temperature by controlling the heater. So generally thermostats and RTD, which means resistance temperature detectors, are used as temperature sensor. And then speed sensor. Speed sensor monitors the rotational speed of drum during wash and spin. It controls drum speed for effective spin drying. It prevents overspeeding, which could damage the load or drum. It balances uneven loads. Speed sensors helps adjust motor speed dynamically. Generally, all effective sensors used as speed sensor. And now discuss about position sensor. Position sensor detects door or lid closer or drum position. It prevents operations if door is open. It ensures drum is in correct position for safe spin start. It avoids leakages and accidents, and also it enables or disables motor or spin functions based on door status. And optical encoders are used for the position sensors. This closed loop control system, I mean speed sensor and then temperature sensor and then position sensor, level sensor, are all the sensors are connect with the control unit. This closed loop control ensures maximum wash quality, minimum energy and water use, safe machine operation. An automatic washing machine is more than just a household appliance. It is a complete mechatronic system. It brings together mechanical parts like drum and motor, electrical components like pumps and valves, and electronic elements such as sensors and controllers. With the help of feedback from sensors, the controller coordinates all operations to achieve safe, efficient, and high quality washing. This seamless integration of different technologies makes the washing machine one of the best real examples of mechatronics actions. Thank you.